Good day and welcome to the Math Salon. I'm Dr. Anumandem. Sorry for my voice today. I have a bit of cold. The question we're going to look at today is about paper 3, Mathematics Advanced Level. So Maths Mechanics. So we'll look at the question that has to do with a position vector movement in a plane of a particle. So the question says, a particle of mass 8 kg moves in a plane so that it has a position vector arrow. Here I'm putting the arrow with the arrow. Sometimes in the exam it's just a bold face. So arrow will be in bold as character. At time t, where arrow is given by t squared plus 2ti plus t cubed plus t squared plus tj meters. At a time t equal to 2 seconds, find the following of the particle. 1. Speed and acceleration. B. Kinetic energy. C. Magnitude of the force acting on it. D. Momentum. So this will give us a chance also to revise some few things about these mechanical quantities. So the first thing we have there is, we see what is given to us. We are given the position vector as a function of t. So we have arrow here. I always do mine with an arrow. Is equal to t squared plus 2t I plus t cubed plus t squared plus t j meters. Actually, on these I and j's, we should also have vectors, small arrows like that, but for convenience, I will not do that. These are unit vectors, so they should also have something like that. But in the exam, you will see them as boldface. They will be in bold. Anyway, our position vector is given like this. That means that the function in the I direction is described by that. So if you want to know how many units you have gone in the I direction, you have to decide at what point you want to do that, at what time. The same thing on this side. So for a particular time t, as we see, we'll be able to have this value at that time t. And then if you look for the velocity at that time, you'll get the speed. If you look for the acceleration at that time, you get the acceleration at that time. So what we have to do here is, I will just remind you about some few things here. Normally, in general, we have r given by, say, f of t I plus g of t j meters. So the idea is that, in general, this as a function of t here, like this function here, with another function, they must not be the same. So I choose another letter to use for that. Then means your velocity, which is defined as the rate of change, so of your displacement. So it's simply going to say, how does the displacement change with time? And we do that as a derivative, differential quantity. So that's dr dt. So that means this is f prime of t I plus g prime of t j. This is meters per second because the top comes with the meter, the bottom comes with the unit in seconds. So this prime just says that the first derivative with respect to t, while the acceleration will be equal to dv dt. So the acceleration is how your speed changes with time. So you have a speed of 10 kilometers per second, and then later it moves to 30 meters per second in a certain amount of time. You can actually know the acceleration. So, but if you look at this v, I already did that. So this is already there. That will be f prime of t, d of that, plus g prime of t, all dt. That will simply mean I differentiate this the second time and that. So we'll write in simple form as f double prime of t I plus g double prime of t j. This is meters per second squared. Because this is already meters per second, the time is second, so it becomes meters per second squared. So this is what we will just apply to get the first part. So to get our speed at the time t equal to 2, first we'll get v. V, we'll see here that v is taken as a derivative of each of these. So I'll take the derivative of this one, and it's simple. So that derivative there is, you differentiate it is 2t plus, if you differentiate this t, it's to the power 1, so it just becomes 2. Remember differentiation, if you want to differentiate t to the n, with respect to t, that's going to be n t to the n minus 1. You know that. So this is 2 in front, then t to the 2 minus 1. So I get that. It becomes 1 power. Then the 2 is there, is it as a constant, t is to the 1. So I multiply in front by 1, so the 2 does not change. But I reduce the power by 1, so it becomes 1 minus 1, and t to the 0 is 1. So we have that here. I plus, here, we differentiate this. This is 3 times t, reduce the power by 1, that's 2. And this is 2t, you do that, reduce the power, and this is 1. But at t equal to 2, the speed will be, I substitute 2 into that equation. So this is 2 times 2 is 4, 4 plus 2 is 6. So this is 6i plus 2 squared is 4. 4 times 3 is 12. 2 times 2 is 4. Plus 12 is 16. Plus 1, 17. So that's 17J meters per second. And the acceleration, so the acceleration A that we just saw is twice the derivative. So I don't have to do that because I already have the first derivative here. So I'll just take this part, dv dt, and that's going to be, I differentiate this once more. So this goes with 1 here, that's 2. T to the 1 minus 1 is t to the 0, so it disappears. There is no t here. Actually, that means t to the 0. So 0 comes down and becomes 0. So we don't do that. This is a constant. We just say that the constant, if you differentiate it, it goes to 0. It doesn't change. So it always remains the same. So the difference will be 0. So we get that. I plus, I come to the second part. If I differentiate that here, I'm going to get 2 times that is 6t. 1 times that is plus 2. Derivative of constant is 0. So that's j. At t equal to 2 seconds, of course, we already saw that. My acceleration would be 2i, that you see, plus 2 here. So 2 times that is 12, plus that is 14. 14J meters per second squared. So we have that. So that's the A part. The next one we go to kinetic energy. This is my A here. So let's just do B here. The kinetic energy, I'll just put it as KE, is defined as half the mass times the velocity squared. Kinetic energy is a scalar quantity. So if I want to use my V here, this is a vector. You have to know that, yeah, a vector quantity when you multiply 2 scalars. So let me say 2 times 3 is just 6. This is a scalar quantity, is just 6. It's not a problem, you get another scalar. But when you have vectors, it's a bit more complicated. Vectors can multiply to produce a scalar, and they can also multiply to produce a vector. So when you multiply two vectors and you get a scalar, then we say that that's a scalar product, sometimes a dot product. But if you multiply 2 vectors and get a vector, we usually say that's a vector product or a cross product. We'll come to the second one. For now, let's see the first one, which results in a scalar. So we say that 2 vectors multiply to produce a scalar quantity, a result that is maybe v squared like that, only if this product is called a scalar product or dot product. And what does it actually say? Say that I have 2 vectors, A, which is equal to, let me say, A1i plus B1j, and B, which is A2i plus B2j. If I want to look for the scalar product of these two, the dot product of 2 vectors is defined in such a way that there is a cos relationship between them. So A dot B is equal to, for example, AB cos the angle between them. So for example, A dot B is equal to magnitude of A, magnitude of B, the cosine of the angle between them. So it means if the angle between these two is a right angle, then the cos of 90 degrees is 0, so it goes away. And you know our unit vectors are in such a way that they are right angles to each other. So any dot product that requires I and J would be 0. So only the I and the I will survive. And then if it is I and I, then it means that, so I dot j is equal to magnitude of I, magnitude of j, cos of 90. And that is 0. I dot I is magnitude of I times magnitude of I, cosine of 0. And that's equal to 1 here. For this case, because these are unit vectors. But the most important that you see ends up being just the product of these two. When we come to an equation that requires cross product like moments, force, then we will see that. So in this case, we will simply write this as half the mass V times V dot V. Because I know if I dot these two, I get a scalar. And that is true here. I already have my velocity. So this is going to be half, the mass is 8 kilograms, we've seen that, times, into brackets here, we have 2t plus 2 I plus 3t squared plus 2t plus 1 j dot the same thing, 2t plus 2 I 3t squared plus 2t plus 1j. I already told you that when we dot two products, only the i's and the j's and the j correspond. So when I dot this with this, I get a result. If I dot this with that, it is 0. So if I take this and dot with this, it's 0. If I take this and dot with that, it survives. So actually what we have here is 4k squared, kilograms, sorry, times 2t plus 2 squared I. Now the I disappears because I dot I, we already saw that is equal to 1 plus 2 or 3 here, the last one, 3t squared plus 2t plus 1, all that squared. So this is what we have. But this should be at the time when t is equal to 2. So at t equal to 2 seconds, then this should be 4 kilogram times, this is 2 here, 2 multiplied by that is 4. 4 plus 2 is 6. 6 squared is 36. And then let's see the second one, plus 2 here, that's 4. 4 with that is 12. And then this is 4 here, plus that is 16, 17. 17 squared, if I take my calculator and just do that. It's 289. Of course, here we get here, this is, because that is meters per second, all that's squared. So if we do that out, we multiply this and sum this up. If we sum this up, we're going to get approximately the multiplication should give you also that. Let's see, should be approximately 1,300 joules. So that's going to be kilogram meter square per second squared. So that's that. So that's the kinetic energy. The most important is that you remember that you can do that, and that the dot product, only the I component and the j components when multiplied by themselves stay. The cross versions, the alternating versions, I and j always go to 0, j and I goes to 0. I will leave this because we will be using some of the result from time to time. So C says the magnitude of the force acting on it. So for C, F is equal to ma, so the mass times acceleration. So if I write force as a vector there, I get that form. But we already saw the acceleration, so we just have to take the mass and multiply by it, because we saw that. But just for you to know, so this is just the same like the mass times F double prime of T I plus G double prime of T J. Yeah, and then that will be in newtons, of course. So if we already had this part, the A here, we were just left to take the value. So this was our acceleration. So this is going to be 8 kilograms multiplied by the A that is here, that is 2I plus 14 J meters per second squared. So if you multiply this out, then that's going to give you 8 times that, that's 16I plus 8 times that, 8 times 4 is 36, 6 and carry 3, 11. That is okay. 32, sorry. 2 and 3, that's okay. So this will be J, that, and this will be Newton. So that is the force that's required then. But they said the magnitude of the force. So this one is a vector. So the magnitude, F, is simply equal to this square, that square, square root. So this is the square root of 16 squared plus 112 squared newtons. I will leave you to finish that off. Then the last one is the momentum. Momentum is a vector quantity, and this is defined as the momentum defined as the mass times the velocity. Actually, our force tries to quantify the change in momentum. So, but if we just have mass times velocity, it's just that's the definition there. This is vector quantity. So we already have velocity that was given there. At the point 2, we already had it. So this is simply going to be 8 kilograms times 6I plus 17 J meters per second. So you can do that, I'll simplify it and you'll get what it's supposed to be. So maybe 8 times 6 here is 48 J plus 8 times 7 is 56, 6 and carry 5, 8 times 9 and 5 is 13 J. So kilogram meter per second. And that was it. Hope you did follow. If not, I have another video that will be showing on another question concerning still this aspect. Maybe with the second one you have a bit more tools to handle your questions. That probably comes or doesn't come, but at least you get the knowledge. Thank you and bye. Remember to subscribe. That helps me to know how many people are following and motivates me to move on as well. But also when I upload a new video, I don't have to put in every WhatsApp group that I'm linked to. Bye.